Good morning, my dear students. Welcome to the chemistry class. And today I'll revise these P block elements, okay, inorganic chemistry part, okay, through problem solution. Today mainly I'll discuss the reasoning based questions, okay. Sometimes you will get some question like interhalogens are more reactive than corresponding halogens, or it may come as ICl is more reactive than Cl2. Now what is the answer of this question? Actually interhalogen bonds are weaker, okay, compared to the corresponding halogen compounds, but fluorine is the exceptional case. Fluorine is very highly reactive, okay. But in other cases, this sentence is correct, okay. The statement is correct. A weaker bond, okay, between two dissimilar atoms is due to the overlapping of orbitals of two dissimilar atoms is less effective. Suppose one is 2p orbital, another is 4p orbital. Definitely here overlapping will be less effective, okay. But when you are taking 4p orbital overlap, okay, then this type of overlap will be more effective, okay, and here the bond will be more strong. So that is why that interhalogen bonds, okay, that will be weaker, okay, compared to the corresponding halogen compounds. Hope you can understand. Next, another type of questions, okay, we have seen that this coming in your board exam, that halogens are colored and the color depends upon the moving down in the group, okay. All of you know that fluorine is a what type of yellowish gas, okay. Chlorine is greenish yellow gas, okay. And if we think about bromine is a reddish brown liquid, or its vapor is reddish brown, and iodine vapor will be violet in color, okay. So intensity of the color increases, okay. So this leads actually what is happening in this case, the color of halogens is due to the absorption of light, that means visible light, okay, that means in the visible region, and this leads to the excitation of the electrons from lower energy level to higher energy level. And fluorine requires high amount of energy, being small in size, and iodine requires low amount of energy, okay, being large in size. Thus fluorine absorbs higher energy violet light and so the complementary yellow color, okay, but iodine absorbs the lower frequency yellow color, okay, and or green light, okay, and so the complementary violet colors, okay. So that is why the color of the halogens, okay, or intensity of the color of the halogens increases moving down the group. Hope you can understand. Next one very important question, that mercury loses its meniscus in contact with ozone. Ozone has some oxidizing property, you know, that it will oxidize mercury to mercurous oxide, okay, which dissolves in mercury, and therefore it starts sticking to the glass and loses its mobility and meniscus, okay. That is why that will not move, and this phenomenon is called the trailing of mercury, okay. So what is the reaction here? That twice Hg is reacting with O3 and forming HgO2, Hg2O, mercurous oxide, okay, and there will be formation of oxygen. Now because of this formation of this mercurous oxide, it dissolves in mercury, okay, and loses its meniscus, okay. So this phenomenon is also called tailing of mercury. Hope you can understand. Next we will discuss another type of questions that are also coming in exams, okay. Xenon gives a series of fluorides, but helium and neon do not, okay. Why? Because xenon has a large size, so from the nucleus to the outermost cell the distance increases, so definitely ionization energy or ionization potential decreases, okay. And in case of helium and neon, okay, they do not contain d orbital, but xenon contains d orbital. Okay, so they can shift their electrons into the d orbital. Okay, that means respective cells, and hence these electrons, okay, can give, okay, in different compounds. Okay, that means a series of fluorides, okay, in case of xenon. But as in case of helium and neon, the ionization potential is high, as well as they do not contain the d orbital, so they cannot promoted their electrons to higher energy levels, and that is why they are not forming series of fluoride compounds. Okay, and they are not actually forming compounds easily. Okay, hope you can understand what I am telling. So here two factors is working. One is that the ionization potential, another is the presence of d orbital. Okay, next one very important question, that is the, all of you know that when you take some dilute HCl or concentrated HCl, when you are reacting with iron, okay, it will form ferrous chloride, not ferric chloride. And you know that ferric chloride is generally formed by direct combination of iron and chlorine. But what is the cause? So here you have to tell that HCl is a mild oxidizing agent, as well as when iron will react with HCl, there will be formation of hydrogen gas, and this hydrogen gas prevents the formation of ferric chloride. Hope you can understand. Next, another type of question we will discuss, that why fluorine not be prepared for a long time from HF and metal fluorides, either by electrolysis or by an chemical reaction. So here you have to tell that fluorine cannot be prepared, okay, for a long time, okay, because it is very much reactive in nature and reacts with the materials of the vessel. Also the aqueous solution of H2F2, okay, that will also produce anhydrous hydrofluoric acid HF, and which is non-conductor of electricity and highly stable, okay, and making impossible to be prepared by electrolysis. Next we will discuss another question, that nitrogen can form pentahalides, cannot form pentahalides, okay, but it can show the oxidation state, that is +5. So though nitrogen exhibits +5 oxidation state, okay, why it is not forming pentahalides? Here you have to write the electronic configuration of nitrogen. So nitrogen, you know that electronic configuration is 1s2, 2s2 and 2p3. In this case there is no d orbital. Okay. In case of next after nitrogen there is phosphorus. Phosphorus there is d orbital. Okay, so that can promote electron from these 2s, that means s and p orbital, to have energy orbital. Okay, that means d orbital. Okay, and can produce 5 unpaired electron. But nitrogen, as there is absence of d orbital, it cannot produce 5 unpaired electron. Okay, because of the absence of this d orbital, as a result this nitrogen cannot expand its covalency. Okay, and it can show maximum covalency 3, and in some cases like ammonium it can show covalency 4. Okay, otherwise, okay, nitrogen cannot show the pentavalence. Hope you can understand what I am telling. Next question I discuss, that hydrogen sulfide is more acidic, okay, compared to the water. So you will think that water, oxygen is there, oxygen is highly electronegative, okay, oxygen is highly compared to the sulfur, so definitely water will be more acidic. But actually here you have to consider the bond dissociation energy, as the size of the sulfur atom is very big, okay, and here the bond length will be high in case of HS, okay, in H2S the HS bond length will be higher compared to the bond length of OH in water, okay. So the dissociation energy will be less in case of H2S, and that is why H2S has lower bond dissociation energy, okay, and it is acidic, okay, more acidic than water. Another very important question we can discuss, that water is liquid but H2S is gas, okay, although the molecular weight increases from oxygen to sulfur. So here you have to tell that about the hydrogen bonding, intermolecular hydrogen bonding, In case of water, it is forming intermolecular hydrogen bonding. Okay, there will be long association, but H2S sulfur is less electronegative, so it cannot form hydrogen bond. That is why hydrogen sulfide is a gas having rotten smell, but water is a liquid. Okay. Next question we will discuss that fluorine gives only one oxide, but chlorine gives a series of oxides. Here also the same reason, that fluorine does not have d orbital and chlorine has vacant 3 orbital, and electrons can jump from that lower energy or orbital to higher energy orbital, and they can produce different series of oxides. Okay, hope you can understand. Next question. It has been very difficult to study the chemistry of radium. To study the chemistry of radon. Okay, helium. You know that helium, neon, argon, krypton, xenon, radon. These are the noble gases. Okay, but radon is radioactive and it is very much unstable because its half-life is very short, as well as radon concentration found in the natural environment. Okay, is very low, okay, to be detected by the chemical means. So it is very difficult. That is why it is very difficult to study, okay, the chemistry of radon. Next question, that SF6 is known, okay, but HCl6 is not known. So here you have to tell that the fluorine size, about the fluorine size. Fluorine size is small, okay, so 6F minus can be accommodated around the sulfur. But as the Cl size is larger, okay, so definitely when you want to try to form HCl6, there will be severe repulsion, and that is not stable. That is why HCl6 is not forming, okay, but SF6 is stable. Okay. Next, another type of questions generally coming, that SF6 is known, but SH6 is not known. Okay. So here fluorine being the strongest oxidizing agent oxidizes sulfur, okay, to its maximum oxidation state, that is +6. Thus it forms SF6. Hydrogen being very weak oxidizing agent and cannot oxidize sulfur to +6 state, thus does not form SH6. Hope you can understand what I am telling. Next question, why are the pentahalides are more covalent than trihalides? Okay, so here you have to tell that higher the positive oxidation state of the central atom, okay, more will be its the polarizing power, okay, which is increases, okay, the covalent character. All of you know about Fajans rule, okay. So according to Fajans rule, okay, if the polarizing power increases, definitely there will be more overlap, okay, as well as more deformation of the electron cloud of the anion, okay, and covalent character increases, okay, and thus pentahalides which have plus oxidation state, okay, central atom has been in the +5 state, is more covalent, okay. In case of trihalide, here it is +6 state, so it will be less covalent. Hope you can understand. Next we will discuss another question, that pH3 has lower boiling point, okay, than NH3. Actually you can think that nitrogen is more electronegative, so here it is very difficult to donate the electron pair rather than phosphorus, but actually it is not, okay. So I am telling about the basicity, okay. Basicity question, actually the question is that why ammonia is more basic than pH3, okay. Here actually the size of nitrogen is small, okay, and that is why the concentration of electron will be higher, okay, compared to the phosphorus. So that is why ammonia will be more basic compared to the pH3, okay. And another question, that is pH3 has pH3 has lower boiling point than ammonia. In this case you have to tell that ammonia in nitrogen is more electronegative compared to the phosphorus, and this nitrogen can form intermolecular hydrogen bonding, okay. So as it is forming intermolecular hydrogen bonding with another ammonia molecule, definitely its boiling point will be higher, and in case of pH3, okay, it cannot form the intermolecular hydrogen bonding, okay, as the electronegativity of phosphorus is less. So here you have to tell that phosphine has a lower boiling point. Next, another type of question that why nitrogen atoms catenation property is less compared to the phosphorus. Actually, carbon has the highest catenation property, okay, because of the higher bond energy. Carbon-carbon bond is very much stable. So here also you have to tell that the property of catenation depends on the bond strength of the elements. See, nitrogen bond energy will be around 159 kilojoule per mole. But if you look at the phosphorus, the bond energy will be 213 kilojoule per mole. So as in case of phosphorus, the bond energy or bondation energy is high, so definitely they are stable, and hence phosphorus catenation property will be more compared to the nitrogen catenation property. Okay. Next we will discuss that SF4 is easily hydrolyzed, but SF6 cannot readily hydrolyzed. Why? Because sulfur atom in SF4 is not sterically protected, okay, as it is surrounded by 4 fluorine atoms, okay. So water molecule can easily attack it. It is getting the place, okay, to attack the sulfur, okay, as well as you know that sulfur vacant orbital is there. But whenever you are thinking that the molecule of SF6, okay, here sulfur is sterically surrounded, okay, or sterically protected by 6 fluorine atoms. Therefore, it is not allowing the water molecule to attack, okay, or to attack into the d orbital, okay, again d orbital. So as a result, SF6 does not undergo hydrolysis, but SF4 undergo hydrolysis. Next, we will discuss about the both oxidizing and bleaching property of chlorine, okay. So question may be asked that why chlorine water, okay, chlorine water showing both oxidizing and bleaching property. So chlorine water will produce nascent oxygen. So I am showing the reaction that chlorine is reacting with water forming HOCl plus oxygen. Okay. Chlorine is reacting with water forming HCl, I think. Twice HCl plus oxygen. So this oxygen is the nascent oxygen, okay. So this nascent oxygen, okay, will be responsible for the bleaching action, as well as this nascent oxygen will also act as oxidation, okay, help in the oxidation. That is why that chlorine water, okay, has both oxidizing and bleaching property, okay. And next we will discuss that if you take some iodine and if you want to dissolve in water, it will not dissolve, okay. But whenever you are adding some potassium iodide, okay, then it is dissolving, okay. So questions may come that why iodine is more soluble in Ki than water. Actually, iodine is covalent, okay, non-polar covalent compound, but water is a polar covalent compound. So solubility of iodine will be very less in water. But whenever you are adding Ki, then it is forming one complex that Ki is reacting with iodine forming Ki3. Okay. So now because of this formation of Ki3, okay, it is very much soluble. Okay. So if you take some potassium iodide and add to water, okay, and you are preparing one potassium iodide solution, then if you add iodine, that will be very much soluble. Okay. So in this way, I have discussed some reasoning based questions, okay, from these P block elements, okay, and I will give some questions also, okay, in your worksheet. Hope all of you will try to answer these questions, okay. And if you have any type of queries or any doubts, okay, that you can ask in my live classes, as well as you can send the questions, okay, through school query button. So today up to this, thank you.